Um, yeah, I was hoping more of you would know a little bit more about microservices, but we can start off by describe. So I'll go into what we currently have today, which is the monolith. So a monolith is basically like, if a good example is a Ruby on Rails application where your full stack is basically in one giant project, and if that process goes down, the whole thing goes down. Hopefully you have some sort of cloud architecture that can proxy to another process, but it can be hard to scale something like this. And when usually it's a lot of projects I've seen when I've done contract work are pretty noodly, and you can make a big monolithic. Obviously, we've done so many monolithic apps that work properly and are good, but there are a lot of problems with it. So what is a microservice? They are small. They're micro. And I'll get into a distinction about small and micro later, because we have had previous history with services, and now we call it microservice because it's cool. So they require explicit boundaries. So a lot of times and because we're also comparing this to libraries, shared libraries, and modules, like what's the difference between just having a library or a module versus having your microservice in some other process? Why do we care? Why do we want to do this? Well, explicit boundaries. You're basically deploying and ensuring that your service is completely separate. So it's a lot harder to add stuff to the service that you wouldn't necessarily want. But with a library, a lot of times you might add stuff that's not necessary to the scope of what it's supposed to be doing. So an SRP is it's a single responsibility principle. It's a key factor in microservices. Do one thing well. They're autonomous. They're independently. They can work independently. So it's nice for decoupling and dependent. You don't have to have all kinds of dependencies. So the benefits. The technology is agnostic. So if you can use Node, you can use Go, Ruby, whatever you want in your little microservice, and you can, you guys and your team can program your little world in whatever language you want. Doesn't matter. You can have isolated failures. I was just talking about, how monoliths, when the whole thing goes down, then hopefully you have another big monolithic process running you can proxy to. A lot of times it has the same exception, so you're just exploding. But it's independently scalable, which is awesome, because it's like even if you had some monolith on top of some of your I guess microservice architecture, you can independently scale certain parts. You can pull off, say, a section in your monolithic app that's having scaling issues, make it into a microservice, make it super scalable, and then start hitting that instead. You have continuous deployment. You can iterate on this much quicker than you could a monolith, because you don't have to worry about all the crap that goes into provisioning, and although some people have issues with provisioning anyway. You can create smaller teams, and so you can isolate, I don't know, if you have guys who are really good at Ruby and guys who are really good at Node, so you can separate them into different teams, and you can explicitly make them work on whatever they want to work on. And they're composable, which is awesome, because you can, you build this, since you've built your microservice in such a small way, and you've had it only do one thing, a lot of times it makes it composable. Say it's like an email microservice. Now that email microservice can be used on all kinds of different things, which is great. And replaceable. Another cool thing is, like I was saying about, let's say you wanted to make it more scalable, or you wanted to make it in another programming language, you can completely replace your microservice pretty easily, because it does only one thing. It's a small piece, and you can just recode it in maybe another language quickly and replace it. So what we were comparing with in the past is SOAP, or SOA rather. the thing about SOA, service-based architecture, is that it's old. We know about it. It was using a protocol called SOAP, and it usually was bigger than the scope of micro. So I think in the historic context of web services, microservices are different and SOAP didn't really solve the need that we needed, because they're more like web services. They're bigger. And then I kind of briefly went over the other possibilities where you're basically comparing the microservice architecture to a shared libraries and modules. And you really have to think about your architecture and break it down to see, microservices aren't always the best option. But when when you really could, benefit from all the benefits I listed before, it's definitely a good thing to look at if you want to separate and use maybe there's another library that's in another language that you want to utilize in your infrastructure. You could put that into a microservice, call out to it using your main app, and be done. Some implementation stuff. Went to microservice, breaking down the monolith. You have to look for your business seams. So you really want a nice way to program things is to isolate your business logic into this nice, thing by itself. And then once you've isolated yourself from the outside world, you can communicate to those external services. So maybe you create a microservice that then communicates with some email service, and then your business layer just talks directly to your microservice. So you might have microservices that talk to microservices, and you get to isolate yourself in your own business logic world and not care about anything on the outside. So you could do all kinds of cool things. But the idea is to find your business seams so that you isolate yourself from the world, and you can create this SRP and composable architecture. And I think I briefly went over this and the benefits. Security is interesting because you can also isolate different microservices to different security profiles, so that maybe you want to isolate this encrypted at rest service, and and I have to speed up, I think. Yeah, so you have to isolate security. Went over technology. REST. So that there's two major microservice protocols: REST and async. One, I have a table here. One is easy to understand because we know HTTP, we know REST. It's really a request response. It's simple. It actually really matters big time because if you're doing a pub-sub architecture, it's fundamentally different than calling out to a service and can be more complex. So I recommend trying to do REST for most of your problems, async for when you think you need it. The great thing about the database side is you can use whatever database you want behind your microservice, right? So you could end up creating like hundreds of databases, and you might even just use like one Postgres server, and you just spin off like 100 databases, but they all do their one isolated task, which is awesome because it can be a pain in the butt when you have huge table architectures, and which is probably a reason that a lot of document databases exist. For deployment, I'd recommend something like Heroku to begin with, AWS with Bosch Cloud Foundry when you can get bigger, and maybe Canonical, and Jay can talk to you about his cool service. And then monitoring is a huge thing. If you have more questions about security, let me know. JWT is a really good way to scale microservices so that you don't have to send off another request in order to authenticate your user. And there are services for that too. And if you have more questions about very specific examples I can't really get into, one was a backend for front end, which is where you can create a backend for cell phone use, one for your API, and then you can call web services behind that. Netflix is a big user of microservices. I have a good book to recommend if you ever want to check it out. It's called Building Microservices. Goes over all this. And thanks.